Okay, welcome to unit review for chapter 4. We're going to be doing number 7 on page 403. Remember, as always, have your books open. Try the problem first before we do it so that we can make sure that we are supporting your abilities and not hindering them. So in this one, we're doing number 7, twins. And this one uses two different likelihood. So the first one we're talking about in the United States, the probability of having twins is usually about 1 in 90 births. So it's 1 out of 90th chance to have twins. This rises to about 1 out of 10 for those women who have been taking the fertility drug Clomid. And among the group of 10 pregnant women, what's the probability of that? And of course, I always read the questions that they're going to be asking of me so I can try and figure out a good strategy. So, what's the probability that at least one will have twins if none were taking the fertility drug? At least one will have twins if all were taking the fertility drug. And at least one will have twins if half were taking it. All right, so let's get started. So, I know that the probability of twins without the drug is 1 out of 90. And of course, we can make that into a decimal if we wanted to. And so it's a repeating decimal, so it's approximately 0.011 and go out 3 places. 1 chance. Probability of having twins with the drug Clomid is a 1 out of 10 chance, or 0.1. So our first question asks us, well, what's the probability that among 10 pregnant women that at least one will have twins if none of them were taking the fertility drug? So in this case, I know that you could either have twins or not. Okay, so 2 outcomes. Probability of having twins never changes, always remains 1 out of 90. And if I'm looking at 10 pregnant women, that's less than 10% of all pregnant women, so I can assume independence. So I do have a Bernoulli trial, and since I'm looking for just at least 1 out of 10, I'm not looking for the second mother to have twins or by the 4th mother having twins. I'm looking for at least 1 out of 10. I'm dealing with a binomial model. So in this case, it's a binomial model, and the parameters are I'm dealing with 10 pregnant women, and the probability of success here is having twins. Okay, so I always write my model because it helps me out in solving the problem. So here I want the probability of at least one having twins. Now we've dealt with at least one before, and in fact we dealt with it in the last unit where we said, well, at least one is the probability of, or the complement of none of them having twins. And it kind of works out the same here. So here if I look at the probability of at least one, that's that it's all greater than or equal to 1. Well, we know your calculator doesn't play nice when you're dealing with the greater than symbol, only it deals with less than. So we have to look at the complement of this to put it in our calculator. Well, the complement of x being greater than or equal to 1 is 1 minus the probability of x equaling 0. So in other words, 1 minus the probability of none. So this equals 1 minus, well, I could treat this as the binomial, or I could treat this like I did before. It's going to come out with the same result. So here I could say, well, how many ways can I select no moms out of 10? And I want none of them to have twins, and all of them to not have twins. This is exactly the same as when I said, well, 1 minus the probability of none, which is 1, minus, well, not having twins is 89 out of 90, and I want that to happen in all 10 instances. So when you were to stick this in your calculator, if I want to know the probability of selecting 0 out of 10, well, that can only happen one way. And also, anything to the 0 just equals 1. So all that you're left with here is this guy, which is exactly the same. So you could do it both ways. And you could put this in your calculator, you could do this as a binomial PDF, you could put it in straight up. Both ways it's going to work out. And in this case, you got that it equals 0.106 or 10.6% chance. Alright, so that's at least one having twins without the drug. If I look at letter B, 7B, it wants us to find out what's the probability of at least one having twins if all were taking Clomid. So now I'm still dealing with the Bernoulli trial, except for this time my model has turned into 10 pregnant women, but the probability of having twins has increased to 1/10. So I'm doing the same thing. So the probability of at least one having twins is x being greater than or equal to 1. Well, if I want to put that in my calculator, I could do 1 minus the probability of none of them having twins, which equals, well, if I want to write this out as a binomial, which is good practice, I'd have 1 minus 10, choose 0, 1/10, I have none of them having twins, and 9/10, all of them not having twins. Put that in my calculator, and I get 0.651. Now this next one's a little confusing, because in this case, I'm dealing with two different things, but I'm going to go with the same principle that we have in the first first two questions, so in A and B. And it says at least one will have twins if half were taking Clomid. So I'm dealing with two different models here. I've got binom. 5 of my moms are not taking Clomid. And the other thing I'm dealing with is 5 of my moms that are taking Clomid. Now, if I want the probability of at least one having twins, remember, that's the probability of 1 minus none of them having twins. Well, in this case, I have to think about not having twins if I haven't taken any medicine, and not having twins if I did. So I'm going to have 1 minus, I'm going to, probability of no twins without, and probability of no twins with Clomid. Well, since I said the word and, it's product. So I have here 1 minus, now it's 5, choose 0. I want nobody to have twins, so it's 1/90th to the 0. All of them to not have twins, so it's to the 5, times, again, 5 over 0, this time 1/10, not having twins, 9/10 having twins. So I can put that in my calculator as a binom PDF times a binom PDF, 1 minus that, and I get 1 minus, or excuse me, I get 0.442. Or 0.442. So there's a 44.2% chance. So Remember in class, I talked about the fact that we always have to reference what we're talking about, so I'm going to kind of model a good sentence with this one. So I would say, according to the binomial model, there is a 44.2% chance that at least one will have twins if half were taking Clomid and half were not. So remember, this is really important according to my whatever model it is that I'm using here. All right, so that is number 7 on page 403.